Hello, how you doing today? Welcome to Mr. Morrow's algebra class. Today we are going to be talking about fractions and mixed number operations introduction. I'm just going to go over some basics today. Should be pretty easy. We're going to go over some vocabulary so that we can really make sure that the concepts of fractions and mixed numbers are solid. And then from there we can go ahead and start on operations like addition, subtraction, multiplication, division, and then some conversions to decimals and percents and all that good stuff. But in order to truly understand how to work with fractions and mixed numbers, you must realize that fractions, decimals, and percents are all different ways of writing the same value. Fraction, decimal, and percent values are part of a whole. Okay? That's why they're the same. They're parts of a whole. For example, 3/4, when you divide that, it's the same thing as 0.75. And then if you multiply that by 100, that becomes 75%. All three of these values are equal. Okay? They have the same value, just different appearances. Today, we're really going to learn how to recognize, simplify, convert fractions and mixed numbers, and vice versa, and find equivalent fractions and mixed numbers. I think it's going to be a really good lesson, so I'm looking forward to it. I hope you are too. In order to work with fractions, decimals, and percents, we have to go over some basics. Sorry about that. Should have said we have to go over. Go ahead and fill that in, please. Fractions. Fractions are part of one whole and are written as follows. You have a numerator and a denominator. It's that simple. The number on the top part of the fraction is called the numerator. The number in the bottom part of the fraction is called the denominator. The fraction 2/5 is read as 2/5 and represents 2 out of 5 pieces which made one whole. So for example, if I had a pizza or a pie here, okay, let's say I had 8 slices. And I shade in these 3. Let's say those are the 3 left and the other 5 slices were eaten. What fraction of the pizza do I have left? I have 3/8 because I have 3 parts out of a total of 8 parts which would have made one whole. When the numerator is greater than the denominator, my friends, it is called an improper fraction. For example, 13/5. That is an improper fraction. It is a fraction, but it is called an improper fraction. And improper fractions can be converted into mixed numbers. How does that work? Well, it's very simple, actually. Let's go ahead and take the example we had. Say we have 13/5. I can convert that into the mixed number very easily by just simply dividing. I'm going to show you all the work, but I usually do this in my head. I ask myself, okay, how many times does 5 go into 13? Well, 5 goes into 13 2 times, which is 10. And I have 3 left over. And that's it. That's my mixed number. I have 2 whole times that 5 went into 13, and I've got 3 out of 5 left over. So this 2 at the top, okay, the answer to the fraction, I'm sorry, to the division, that is my whole number. The remainder here, that is my numerator, and the dividend outside the divisor, I'm sorry, outside of the fraction, the division bar, that is my denominator. So I have 2 3/5. Now, how do I go from mixed number to improper fraction? Very simple. Let's say I have 3 4/7. I'm going to take the denominator. I'm going to multiply it to the whole number. So multiply. That's 21. That sum, I'm going to go ahead and add to the numerator. So 21 plus 4, that will be 25/7. And then you can check it. 7 goes into 25 3 whole times with 4 left over. So that all works out. So that should just be a little refresher. I hope that was easy for you. If you forgot how to do it, well, guess what? Now you know. So that's awesome. Now let's go over some concepts and vocabulary. When we're talking about fractions, not today so much, but when we're adding and subtracting and multiplying and dividing and simplifying, so we're going to use it a little bit, we have to know what factors are. And factors are numbers that go into other numbers evenly without a remainder. Factors are always less than or equal to the original number. For example, the factors of 20, the way I find the factors of 20 is I always start with 1. I go from 1 to 10, and I ask myself, okay, 1 times what is going to give me the number in question? All right, so in this particular case, 1 times 20 will give me 20. So those are two values already. Those are two factors. 2. Does 2 go into 20? Yeah. 2 times 10. So now I've got 4 factors. 3 does not go into 20. 4, sure it does. 4 times 5. 5 I already have. 6 does not go into 20. 7 does not go into 20. 8 does not go into 20. 9 does not go into 20. 10 does go in, but we already have it. So there you have it. In order from least to greatest, all of the factors. Very simple. Now, when we're talking about factors, sometimes they're going to ask you to find a prime factorization, or when we're adding and subtracting and multiplying and dividing, sometimes you need to know what kind of factors or multiples are valid for that use. And sometimes these numbers are called prime. And a prime number is a number whose factors are only 1 and itself. Examples of prime would be 2, 3, 5, 7, 9, 11, 13. Notice that 0 is not prime and 1 is not prime. Okay, the first prime number is 2. 0 and 1 are not prime. So those are prime numbers. Now what's the opposite of prime numbers? Composite numbers. Composite numbers, there's a number that has more than 2 factors. For example, the number 9. 9 has the factors of 1, 3, and 9. So being that it has more than 2 factors, it is called composite. Now, how does this help you? Well, the concept of prime factorization is very important. Okay, one sees that a lot when we're trying to find LCMs or trying to simplify fractions. And it is the process of breaking down a number into its primes. For example, the prime factorization of 24 is, let's check it out. We take 24. To find the prime factorization, I want to break it down into its primes. Give me 1 second here, guys. This is bothering me here. Okay, sorry about that. Okay, so the prime factorization of 24. Well, let's see. What are 2 factors of 24? I'm going to go ahead and say 3 times 8. 3 is prime. 8 breaks up into 2 times 4. 2 is prime. 4 breaks up into 2 times 2, which are prime. So the prime factorization of 24 is 3 times 2 to the 3rd power, or 2 cubed. That is the prime factorization of 24. So prime factorization is when you break down a number into all of its prime factors. And what's a multiple? Multiple is the opposite of factors. A multiple is products of natural numbers. That's in a nutshell what it is. It's whole values times whole values. That's going to give you multiples. Multiples are always greater than or equal to the original number. For example, the first 5 multiples of 4, well, to get multiples is very easy as well. Start with 1. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. Not 14, 16, sorry. 4 times 5 is 20, etc., etc. It will go on forever because 4 times 1 billion is 4 billion, and that is a multiple of 4. That's why factors are less than or equal to the number in question. Multiples are greater than or equal to the number in question. All right, let's continue. Now that we've already introduced factors and multiples, let's talk about what the greatest common factor is and what the least common multiple is. The greatest common factor is the largest common factor between two or more numbers. If you know your multiplication tables and the divisibility test for numbers, it is very easy to find the GCF of two or more numbers. The LCM is the opposite. The LCM is the smallest common multiple between two or more numbers. If you know your multiplication tables, it is very easy to find the LCM, or least common multiple. Now, let's go ahead and do an example. Let's find the GCF and LCM of 18 and 30. Very simple. Please follow these directions. 18 and 30. Again, if you know your times tables, you could probably already know both of these answers, but let's just say that you still need some refreshing. Let me show you a nice, easy procedure. First of all, break down each number into prime factorization. So 18 is going to be 9 times 2. 9 is going to turn into 3 times 3. We're done with the prime factorization there. 30 is 3 times 10. 10 is 2 times 5. Okay, so we've broken them both down into the prime factorization. So in order to find the GCF, okay, remember this. Every pair of numbers, okay, you have the same number on both sides. Every pair comes out as one value. So please notice, I'm taking a 3 from the left side, and I match it up with a 3 from the right side. Every pair comes out as one value. There is not a 2 on both. Oh, well, there's another one. There's a 2 and a 2. So I multiply that to the 3. So my GCF is 6. Okay? This 3, there's no other 3s, so I can't take out another 3. And there's only one 5, so I can't take out that 5. So my GCF is the product of the values that you found pairs for. And every pair comes out as one of that value. Let me just do that again, just to make sure you understand. Okay? So, you want to find the GCF, and the GCF is the product of all pairs that come out as one value. So if you notice, I have 1 3 on the left, 1 3 on the right, so that comes out as a 3. Times 1 2 on the left, 1 2 on the right, so that comes out as a 2. So the GCF is 6. Okay? Hope that makes sense. Now, let's look at the LCM. The LCM equals the GCF, so you got to find the GCF, times, multiplied by, all left over primes. So let's investigate this one here. For this guy, we know that the LCM is going to be the GCF, which is 6, times the leftover primes. I'll do the leftover primes in green so you could see. So times that 3, which was left over, times that 5, which was left over, and boom, you're good. So 6 times 5 is 30 times 3, so 90 would be my LCM. And from LCM, we can go ahead and continue to LCD, which is the least common denominator. Once you recognize or find the LCD, the least common denominator, it's your job to convert or express the given fractions as equivalent fractions. Okay? Very, very simple. So for example, find the LCD of each set of fractions, then convert each fraction. Well, let's think about this. We have 12 and 15. I need to find the LCD. I don't know it off the top of my head. Actually, I do, but let's just pretend I don't. I've got a 12 and a 15. I know that my LCM equals the GCF times all leftover primes. All leftovers. Okay? So the 12. 12 breaks down into 3 times 4. 4 breaks down into 2 times 2. 15 breaks down into 3 times 5. So first things first, I got to find my GCF. My GCF here is, I've got a 3 and a 3, and that's all I've got. That's my GCF. My LCM is going to be the GCF of 3 times, I'm going to do the leftovers in red so you can really see what I'm doing, times a 2, times another 2, times a 5. So my LCM is going to be 60. That's my LCM. So that's the first part. So my LCM equals 60. Now, how does that help me to convert each fraction? Well, I think that's the really easy part. Once you know what the LCD is, it's pretty simple. We know that 5/12 has to be converted to something over 60. Well, the question is, what did I multiply to 12 to get to 60? The answer is 5. And if you remember, whatever you multiply or divide to the numerator, you must multiply or divide to the denominator. So if 5 times 12 is 60, 5 times 5 would be 25. That is 5/12, but converted with a denominator of 60. And I know that 4/15 has to turn into something over 60. So 15 times what gives me 60? Well, that's going to be a 4. Whatever I multiply to the denominator must be multiplied to the numerator. So that would be 16/60ths. And that is how I find and apply the LCD. Now we use a concept called equivalent fractions here. So I want to go ahead and explain that. Equivalent fractions. Equivalent fractions are fractions that have the same value with a different appearance. That's exactly what we just did in the last example. To find equivalent fractions, simply multiply or divide the same value to both the numerator and denominator. When you divide by the same value to both the numerator and denominator, you're reducing the fraction to lowest terms. In order to find equivalent mixed numbers, you must first convert it into an improper fraction, then multiply and divide the same value to both the numerator and denominator, and then you go ahead and turn it back into a mixed number. Let's do a couple of examples there about that. For example, find 3 equivalent fractions for, okay, A. 3/5. Well, I'm going to multiply the top and the bottom by the same number, so I'm going to get 6/10. Then I'm going to go ahead and multiply the top and the bottom by, I don't know, 3/3. So that's going to give me 9/15. And then I'm going to go ahead and multiply the top and the bottom by 4/4, which would give me 12/20. All of those are equivalent. Why? Because I multiplied the same number to the numerator and denominator. Why does that make it equal? Well, if you ask yourself, what is 4 divided by 4? The answer should be 1. And isn't anything times 1 itself? So in essence, when I multiply 3/5 to 4/4, I'm really just multiplying 3/5 to the value of 1. So I'm changing the appearance, but not the value. 2 3/8. 8 times, remember, we got to convert it to mixed number. So 8 times 2 is 16 plus 3, that's 19/8. All right, let's find an equivalent fraction. Let's go 2/2. So that's going to be 38/16. Let's go 3 over 3, that's going to be 57/24. Let's go 4 over 4. That's going to be 76/32. All of those guys are equivalent fractions or equivalent mixed numbers. Now, I should have done something, and I'm sorry that I didn't, because we're technically not done here. Sorry about that. If they're asking you to find 3 equivalent mixed numbers, I need to now convert these back into mixed numbers. 16 goes into 38 2 times, because 2 times 16 is 32. And there's 6 left over. So I've got 2 and 6/16, which I can reduce to, let's see, I can divide both by 2. So that'll be 2 and 3/8. Okay, so you do have to, unfortunately, turn it back into a mixed number. Okay? Hope that makes sense. And then reduce 24/40 to lowest terms. We're going to use equivalent fractions again. I got 24/40. I want an equivalent fraction that is in lowest terms. So I'm going to just divide the same value to both the numerator and denominator until the greatest common factor between both is 1. So, okay, what goes into 24 and 40? Well, I know that 8 goes into 24, and I know that 8 goes into 40. 24 divided by 8 is 3. 40 divided by 8 is 5. That's it. I'm done. That is simplified to lowest terms. I hope you learned a lot today. I really appreciate you listening, paying attention, and taking notes. Have a wonderful day, and I'll see you tomorrow. Bye-bye.